Alright guys, this video is on solving simple logarithmic inequalities. So whenever I give you a problem with an inequality, I'm going to let you use your graphing calculators to do it. In the book it says solve using a table or a graph. And I mean, you can use both, but the graph is the most visual, easy way to do this. Alright, let's start with an example. 5 to the x power is greater than 8. So in your graphing calculator, in y1, I want you to put 5 to the x power. And in y2, I want you to put 8. And then graph it and take a look at the screen. Now I'm going to color code this one. I'm going to let the y1, the 5 to the x power, be yellow. And that's this one. And remember, it approaches the asymptote. And then I'm going to let y2, the 8, be green. And that's this line. So that's this one. This is this one. We want to know where is the yellow one. And then where you see greater than, I want you to write above or below. Greater than means above. So where is the yellow above the green? And that would be all of this part. And then going on. So once you do that, I want you to draw a dotted line down to your x-axis and shade all the x's that correspond. And it goes on as well. So what we need now is just that starting x value, and then we can say x is greater than, because it goes to the right, x is greater than that value. So in your calculator, you just do second calc intersect, to get that value where the two lines cross, to get that x value. And for this particular one, it's 1.292, so we will say x is greater than because it's to the right, but we're not going to put equal to because we didn't have equal to in our original problem, so greater than 1.292. And that would be the solution to the inequality. All x is greater than that number, if I plugged them in as this exponent, would make 5 to the x greater than 8. Alright, for this next example, we are going to find where 3 times 1/2 to the x power is less than or equal to 6. So in y1, we're going to put 3 parenthesis 1 over 2, close it, raise it to the x power. And in y2, we're going to just put 6, and then we're going to graph it and look at it. So when you graph it, it's going to look like this. y1 was the exponential, so that's the curvy part, and y2 is the line. And we want to know where is the curvy part, the yellow part here, less than or equal to the green part. So I want you to write down less than is below. So we're going to shade all of the yellow part that's below the green part. And it keeps going. So I'm going to draw a dotted line down to my x-axis and shade all the x's that correspond. So it's going to be another x is greater than because it's to the right, greater than or equal to this time because it is touching. And then we just need to do a second calc intersect to find that value. And when you do that, that value is actually at x equals -1. So x is greater than or equal to -1. And when your instructions, like on your homework and your quiz and your test, say use a table or graph, I want to see a sketch of the graph with things shaded, just like I have here. Alright, so let's now do one with a logarithm. We have log base 5 of x is less than 1. So in y1, I want you to put log base 5 of x. You just use your log base function. And in y2, put 1 and graph it and look at it. Now I changed my window on this a little bit just so that I could zoom in and see it better. But the yellow one is the logarithm. And remember, it does approach an asymptote right here. And then the green one is our line y equals 1. Oops, there we go. And we want to shade where the yellow part is below the green part. So we want to shade everything from here on down. And that corresponds to x values from here. Now be careful because it doesn't go to the left infinitely. It stops at your asymptote. Your asymptote's like a big wall that it hits and it can't go past that wall. So your x values that it corresponds to are only the ones between here and here. So this has a left and a right boundary. So if you do your second calc intersect, you'll find that that x value is 5, and then if you should already know that your asymptote is at y equals 0. So our x values that satisfy this inequality would be all the x's between, but not including, because this one was non-inclusive, so between 5 and 0, like that. All right, one more example. We're going to go log base 2 of x is greater than or equal to 3. So in y1, I will put log base 2 of x. And in y2, I will put 3. So there's the green part and the yellow part. Graph it and look at it. So we see that the logarithm is the curve approaching the asymptote. And 3 is this line here. And this time we want greater than or equal to, so right above. Where is the yellow one? Above the green one. So we're going to shade all of this stuff. And there's no boundary on the right here. It goes on forever to the right. So the only boundary we have is on the left. We need to do second calc intersect to find that value. And I think you come out with actually an x equals 8. So I shouldn't have shaded all of that here. Sorry. 8 on out. So we would say x is greater than, and then we used an equal to because we had an equal to in our original, greater than or equal to 8. And that's the solution for that one. All right, so that's it. You guys have a good night, and I'll see you tomorrow.